more than 50 million people have tested positive for coronavirus in the world, of which 1.3 million people have been deceased because of it. Take this into consideration. 11 million people in the United States have been diagnosed with this virus, and 245,000 have died because of it. Scientists have turned to genetic engineering in finding vaccines, hoping to use previous methods of vaccine creations. There have already been several successful vaccines in development. Experts anticipate that these successes, that advancements in genetic engineering could substantially shorten the development timeline for the COVID-19 vaccine.
You might be wondering, how do they actually create these vaccines? And what they do is they gather the virus's genetic information and they create a copy of selected antigens, and which are made up of DNA and RNA molecules. And then they use those copies of the glucose molecules and they inject it into human cells. And then the cell uses their machinery system to make antigens that the immune system reacts to. And a few industries have been using the DNA plasmid approach. However, researchers have portrayed that RNA vaccines have been more efficient than the DNA plasmid approach when it comes down to mobilizing the immune system, which creates higher antibodies and just it's more stable to use.
As of now, the timeline for vaccine development are as follows. More than 120 vaccines are in early stages of development around the world. The hope is that an effective and safe vaccine can be produced by the end of 2020 or early in 2021, which would be an astonishing accomplishment. It takes about 5 to 10 years to develop a vaccine on average. The most rapidly developed vaccine was a mumps immunization, which still took 4 years to develop.
There have been key developments in the manufacturing of genetically engineered COVID-19 vaccines. In fact, a biotechnology company called Inovo Pharmaceuticals used the DNA plasmid approach, which was used to find a vaccine for the MERS virus.
So far, 3 companies are leading the race to a vaccine. On November 9th this year, Pfizer and its partner BioNTech reported a much better than anticipated results. The vaccine being tested has shown to be more than 90% effective. Another company, Moderna, has reported its vaccine to be about 95% effective. And a third company, AstraZeneca, has reported a vaccine effectiveness falling in between 62% and 90% effectiveness. If approved by the FDA, a limited amount of the vaccine will be globally produced, with around 50 million doses produced by the end of 2020 and another 1.3 billion by 2021. An effective vaccine would offer protection for a long time and make it a lot easier to finally put the current health crisis to an end. Other possible problems with genetic engineering is that there isn't much of a set regulation, which can be dangerous. You see, there have been some concerns stated by researchers on adding additional regulations in gene editing and restrictive synthetic biology technologies in order to avoid possible setbacks. Because of these reasons, there has been division for a ban on human gene editing.
Based on the news around the world, it has been said that EU has limited and restricted their safety guidelines in hopes of speeding up the process of creating a vaccine. However, this action possesses risk to the people in the environment, and it also brings up the question whether or not our vaccines are in fact going to be effective or not if there are no certain guidelines in creating them.
In addition, the EU has been heavily invested in vaccine development as of currently. The stocks have increased significantly for vaccine creating industries, such as INO, Johnson & Johnson, Pfizer, and many other companies. With these new investment implications, many possible dangers will be presented and may obstruct the path of finding a safe vaccine. This is due to the lack of precaution, which creates a risk in the vaccine development program, and it should be examined thoroughly. There have been reports on scientists demanding stricter rules that are unfortunately receiving no attention.
With governmental aid of up to $483 million promised, there is hope for mass production to proceed if trials go well. While the farthest vaccine candidate is at stage 3, scientists are pushing for many different types of vaccines in order to find the most effective one. The pressure on authorities to present an answer has led to an abundance of misinformation regarding an approved vaccine in states. 20 trials are underway, and there are a few that should be highlighted, as they are the ones that are making the most headway. The first clinical trial that has made significant headway is a vaccine using the inactivated virus to produce vero cells using a randomized, double-blind, placebo parallel controlled setting.
Other countries such as China has taken vero cells to study the same guidelines, except they have chosen to use the previous SARS-CoV-2 disease. These are currently both in stages 1 and 2 of testing, but they are showing promise despite their slow progress. And phase 1 was conducted with 150 healthy people, double dose, and a schedule of 28 days apart. And stage 2 was conducted to evaluate the safety, the reactogenicity, and immunogenicity of the vaccine. Basically, how the human body will react and how the body creates an immune system in reaction to the vaccine. Phase 3 is also being finalized and is going to be conducted with 30,000 participants. Our goal is to create a vaccine that is not only effective and safe to be used, but one that is able to be mass produced. Industries such as Pfizer and Moderna have been able to create a vaccine that is 90 to 95% effective. This goes to show how well genetic engineering has played a role in our progress. Thank you for your time, everybody.
We hope that you learned something about our presentation.
Regarding genetic engineering and its applications in making a COVID-19 vaccine.